In this section, we are going to look at the different units for concentration of a solution, followed by problems on dilutions. The concentration of a solution can be expressed as one of the four following units: mass percent, volume percent, mass per volume percent, and molarity. As you can see in this slide, we have the different equations for mass percent, volume percent, and mass per volume percent. Even though I'm introducing to you guys these equations, understand that you will not be tested. So you will not be tested on this material. But understand that it is important to know that maybe in your future careers, you will be encountered with solutions that they give you the mass percent. And when it comes to the mass percent, understand that the mass percent specifically talks about how many grams of solute we have in grams of solute plus solvent. In other words, grams of solution. When it comes to volume percent, understand that the number given to you is the milliliters of solute divided by the milliliters of the solution. Remember that each one of these is going to be multiplied by 100%. And lastly, if we're talking about a solution that is mass per volume percent, that means that we have grams of solute divided by milliliters of a solution, and as you can see, times 100%. So again, even though there may be some problems in the suggested list, I will not be testing you in quizzes or exams with the units of concentration of mass percent, volume percent, and mass per volume percent. The one that you guys are responsible for is molarity. And when it comes to molarity, it is defined as the moles of solute divided by the liters of the solution. So as you can see, if we have a 1 molar solution of sodium chloride, that means that we're going to have 1 mole of sodium chloride in 1 liter of the solution. So the figure that you guys see to the right is just expressing how we create a solution that is 1 molar NaCl. So this means that if we're creating a 1 molar solution of NaCl in a flask, you're going to place 1 mole of NaCl or sodium chloride, and then you're going to put the volume up to 1 liter. But actually, let's do a math problem to see how we calculate molarity. The sample problem reads, what is the molarity of a 0.500 liters of NaOH solution if it contains 6.00 grams of NaOH? So the first thing that you have to take into account to do a problem like this is to write the equation for molarity, which states that molarity, and the unit is capital M, equals moles of solute divided by the liters of the solution. So understand that solution, the shorthand that I utilize is SOLN. So the word solution, as you can see, that's the shorthand that I utilize. Now, let's just write down the numbers that are given. So in this case, we have given the volume of our solution, which is 0.500 liters. And we also have the grams, so the mass of the solute, which is specifically 6.00 grams in our compound is going to be sodium hydroxide. So Because molarity is moles of solute divided by liters of the solution, that means that our first step will be converting grams of NaOH to moles of NaOH. And in chapter 7, we learn how to convert things from grams to moles. So we're going to write down the amount given, which is 6.00 grams of NaOH. And when we're trying to convert this to moles, we're going to divide by the molar mass of our compound. So to determine the atomic mass, the mass number or the molar mass for our compound, remember that we are going to add the mass of sodium, the mass of oxygen, and the mass of hydrogen, which are the three elements that are present in this compound. So when you do that math, if you utilize numbers in which they're rounded to 2 decimal places, you will find out that the mass of this is 40.00 grams of NaOH in 1 mole of NaOH. So when we do that, we are going to take 6 divided by 40. So that means that we have, in this instance, 0.15. And because we want to keep the same number of sig figs, we're going to add a 0 because there were 3 sig figs in the first amount. And this is moles of NaOH. Then, now we have the correct amounts in order to put them in our equation. So, as you can see, the moles of NaOH now we're calculated, and we already have the volume of NaOH. So, what we're going to do to finish the problem is say, in this instance, I have 0.150 moles of my solute, and I'm going to divide it by the volume of my solution, which is 0.500 liters. And when I divide these two numbers, I see that we have 0.3 moles. But again, when it comes to this, remember that we have to keep on our sig figs, and we have 3 sig figs here. We have 3 sig figs here. So even though this is our result, our final answer is going to be reported as 0.300 capital M, because capital M means molar. So let's continue practicing this by doing first problem in our worksheet and the second problem in our worksheet. The first problem reads, how many grams of ammonium carbonate are needed to prepare a 0.5 liters of a 0.50 molar of ammonium carbonate solution? So let's just write down at first what is given to us. What we have given in this problem is the molarity of our solution, which is 0.50 molar. And we also have the volume of our solution, which is 0.5 liters. What we're trying to find in this problem are the grams of solute. Remember that the equation for molarity states that molarity equals moles of solute, which I'm just going to write the word moles, by liters of the solution. So if I'm trying to find grams of solute utilizing this equation, then I need to rearrange it to express the moles of the solute, which means that the moles of the solute are going to equal the molarity of my solution multiplied by the volume in liters. Okay, so that's the first operation that we're going to do. We are going to multiply 0.50 molar by 0.5 liters. When we multiply those two numbers, we get a value of 0.25 moles. So at first we have the moles of this particular compound, which is ammonium carbonate. Now, if we have ammonium carbonate present, and we already have the moles of it, one of the things that we should do is find the chemical formula for ammonium carbonate. Following the rules that we learned in chapter 6 for determining the chemical formulas of ionic compounds, we know that ammonium carbonate, its chemical formula is going to be NH4, and in parentheses, a 2, CO3. Why is that important? Because when we multiplied the molarity times the volume, the moles that we obtained, that is of our compound, NH4, 2CO3, but the problem is asking specifically for grams of solute. So in this instance, we need to convert those moles to grams. So in this little corner on the top of the page, I'm going to do the conversion from moles to grams, which states that if I have 0.25 moles of my solute, which is NH4 in parentheses 2CO3, and I need to convert that to grams, then I'm going to multiply by the molar mass of this compound. That if you use the numbers for determining the molar mass to 2 decimal places, it will be 96.09 grams in 1 mole of the compound, which is, again, NH4, 2CO3. So when we do this, understand that the final answer, because if we look at the sig figs from the beginning, we have 2 sig figs, we have 1 sig fig. So even though we get a value that is around 24 point something, we need to round it to 1 sig fig. So your final answer is 20 grams. Let's do the second problem. It reads, if 0.885 moles of copper 2 sulfate are dissolved in enough water to make a 0.070 liters of solution, what is the molarity of the solution? So first, let's write down what is given, which in this case, we have the moles of solute, which is 0.885 moles. And our solute in this case is going to be copper 2 sulfate. And we also have the volume of the solution, which is 0.070 liters. So in this instance, we just plug in the numbers. We know that molarity equals moles of solute divided by liters of the solution. So we take our numbers, 0.885 moles, and we divide it by 0.070 liters, and we obtain a value of 13 molar. Remember that the unit for moles is molar. If you want to review the sig figs for this, remember that the first value has 3 sig figs. The second value have 2 sig figs. So that's why we report 2 sig figs. The answers for problem 3 and 4 you can find in the answer key. The last topic that we're going to talk about is dilution of a solution. So understand that in a dilution, we are going to add more solvent to our solution. Okay? So it is important to note that when we are diluting a solution, we are going to be increasing its volume. This is going to affect concentration because it's going to decrease the concentration of a solution. But understand that in any of these systems, once we do this, because we are not changing the amount of solute, there is no change in the amount of solute of the solution. Whenever we're doing a dilution problem, understand that that is going to be given by the equation M1V1 equals M2V2, which means that this by definition is the initial molarity, and the initial volume is going to equal the diluted molarity by the diluted volume. So let's do the following problem, which states that we are going to try the final concentration, meaning we're going to find M2 when we have a solution that has a volume of 0.50 liters and it starts at 6.0 molar, and we're talking about an HCl, and we are going to dilute this to a final volume of 1.0 liters. So let's just write down everything that is given. We have the initial molarity, which is 6.0 molar, and this is a solution of HCl. We have the initial volume, which is 0.50 liters. And we also have the final volume, which is 1.0 liters. So when we do this, remember that our equation states that M1 times V1 equals M2 times V2. So in this case, we're solving for M2. So the equation, we need to rearrange it as M2 equals M1 times V1, everything divided by V2. So since all these variables are given, then we plug it in into the equation. We have 6.0 molar times 0.50 liters divided by 1.0 liters. Each one of these numbers has 2 sig figs. So when we multiply 6.0 times 0.50 and we divide it by 1, we notice that the value that the calculator gives us is 3, but we need to report 2 sig figs, so we're going to report it as 3.0 molar. Now let's follow and do some problems from the worksheet. For this, I'm going to just do the first problem. The answers for 2 and 3 you can find in the answer key for the worksheet for chapter 9. The first problem reads, if 30.0 milliliters of a 12.0 molar HCl stock solution are diluted to a volume of 500 decimal place milliliters, what is the molarity of the diluted solution? So when we're doing dilution problems, the equation is M1 V1 equals M2 V2. Remember that these values are going to be multiplied. Let's write down what is given. In this instance, we know the initial volume, which is 30.0 milliliters. We have the initial molarity, which is 12.0 molar for HCl, and we have the final volume. So we have V2, which equals 500 decimal place milliliters. One of the things that I want to express when it comes to this is that for dilution problems, you don't need to change the units to liters unless the units in the problem do not match. What do I mean by that? That if a problem has an initial volume in milliliters, but it gives you as a final volume liters, then you need to make those unit matches. But in this problem, because we have the first volume in milliliters, the final volume in milliliters, so you don't need to express them as liters. You can use them as that is. So for this problem, we have to find M2, which means that our equation needs to be rearranged. So M2 is going to equal M1 times V1, everything divided by V2. And when we plug in our numbers, we have 12.0 molar multiply by 30.0 milliliters. All of that is going to be divided by 500 decimal place milliliters. And the final answer for this problem, 12 times 30.0 divided by 500, determines that the calculator display says 0.72, but because we need to keep 3 sig figs, it's going to be 0.720, and the unit will be molar.